Hi guys! Welcome to another episode of DFI Tech Insight. I'm your host and I'm super excited to have you join me again. In today's episode, we will be discussing all RF designs. RF design can be a tricky endeavor. It takes a lot of experience and knowledge to get the right results. So today, we are at DFI, a leading global provider of high-performance computing technology across multiple industries, here to help you get started. To start with, what is RF design? What are some of its applications? RF circuit design is concerned with developing circuits that operate at radio frequencies. RF stands for radio frequency, which represents the oscillation rate of electromagnetic waves. RF can refer to frequencies as high as 300 GHz or as low as 30 kHz. RF applications are everywhere. From radio broadcasting to wireless communication to remote control, RF is on its way to becoming an indispensable part of your life. Here are some applications. Radio broadcasting. AM/FM radio has been around since the 1920s and is still a staple in many households. However, according to industry experts, it's not going anywhere soon. US. FM radio stations will be broadcasting a maximum power of 100 kilowatts by 2023. RF remote control. Sure, you can use your smartphone or tablet for this task now, but what about when you're away from home? With RF remote control technology like RFID tags and chipsets that can communicate with other devices over long distances, up to 200 kilometers, you'll be able to control everything from your garage door opener to your drone from anywhere in the world. Wireless communications. 5G is already here, and it's going to get even better. By 2025, we should see speeds of up to 10 gigabits per second Gbps. This will allow us to download movies in less than 2 seconds and stream full HD video at 30 frames per second. When you think of RF design, you might imagine a room full of electronics and cables, but the truth is that there are many different types of RF designs and interference. When it comes to Wi-Fi/5G interference from onboard components, attaching an antenna to the outside of the chassis can effectively prevent it. Still, antenna placement and circuit design on the board is critical for the need to put it inside. Some design issues are easy to spot, while others are far more difficult. When the power consumption is too high, you can typically find the problem area by sticking your probes in the right place. When your CPU is sitting idle because you have the wrong memory type or insufficient memory, that's easy to spot and fix for an experienced engineer. However, the world of RF is a virtual unknown for most engineers. Typically, system makers look for RF vendors to supply them with a black box part. This means that the black box contains all the components necessary to operate the RF subsystem properly. No tuning is needed, and all that's likely required is some passive components. In this case, they typically attach the antenna to the outside of the enclosure for sound signals. Engineers do have the option of designing the RF subsystems within the chassis, including the antenna. However, what do you do when that RF subsystem is affected by interference from other components on the board? First of all, how would you even know that it's happening? Issues like this are far more common than you might expect. The research and development team at DFI are well educated in this area of radio frequency interference, better known as RFI and electromagnetic interference, EMI, and they are here to help. The problem could be very complex, with some components that don't work well with other elements. Or it could be relatively simple, where moving an antenna to a different angle or place in the system solves the problem. Remember, your devices must work together properly to provide the best possible user experience. RFI impact. Some applications are relatively innocuous, like a simple EOT device. And then there are others where lives could be at stake, like in the case of the Boeing 737. Recently, the FAA warned Boeing that its radar altimeters could be affected by 5G internet service. This means that the working frequency band of the radar altimeter causes interference from the 5G radio band in the 3.7 to a 3.98 GHz frequency band, causing unreliable performance of the radar altimeter. Like any environment, you need the RFI to be quiet. Minimal noise present will improve the antenna's reception. Various regulations are in place to ensure that electronic devices control the energy value of unintentionally radiated EMI and that unnecessary electromagnetic wave radiation energy in space does not interfere with wireless communication functions. However, your average motherboard designer may not be aware of these regulations or may think they don't apply to this simple motherboard. With multiple power and ground planes in devices operating over the entire frequency spectrum, EMI and RFI are likely. Proper planning for the signal routing is vital, as is using high-frequency signal simulation and analysis, impedance matching control and continuity, and avoiding discontinuities in the signal paths. And the impedance characteristics of each part should be adjusted at high frequencies. This combination of complexity and density of the electronic components makes every signal a potential source of unintentional radiation. The space around the motherboard is full of electromagnetic waves at fundamental and harmonic frequencies that interfere with the frequency band used by wireless communications. Proper antenna placement. One fundamental question for developers is where the antenna should be placed. The angle and position must be adjusted so that the antenna receives proper signals rather than useless interference. Typically for IPC or embedded box PC, antennas are attached to the outside of the case. While this simplifies the design, it also uses the metal casing as a shield against RFI generated from the motherboard and avoids many of the interference issues. For applications that can't handle the external antenna, DFI experts have developed a workable solution that puts the antenna inside the chassis yet does not cause interference. To avoid interference, other components inside the system must also be shielded from RFI, such as DDR modules, clock chips, PWM mics, etc. Placing them inside metal cans or another shielding may sometimes help, but that can be expensive or even less effective. Based on DFI experience, the most effective way to reduce the radiation of RFI energy is to design the shielding on the motherboard while planning the signal routing on the PCB. In addition to the hardware design, the software design must also be tuned to reduce RFI for systems that operate in the RF spectrum. This is yet another area where the DFI experts can help. For better or worse, 5G and other RF-related technologies are becoming indispensable to today's society. As more radios are added, the number of antennas grows. As a result, developers must adapt. The DFI experts are standing by to help. Do you need to put the antenna within the enclosure? Or are you in need of an innovative design or premium management system? Contact us at DFI today. DFI industrial-grade solutions enable customers to optimize their equipment and ensure high reliability, long-term life cycle, and 24/7 durability across a wide range of markets, including industry automation, medical, gaming, transportation, energy, mission-critical, and intelligent retail. This is where I draw the curtains on today's episode of the Insert Name podcast. I am sure you wouldn't want to miss the subsequent episodes, so like and subscribe to my podcast. Also, follow us on our social media channels so you do not miss out on any information. Thank you all so much for listening to my show. See you soon.